Physics of Volleyball by Emily Faith. What is volleyball? A sport played across the world in competition, recreational play, and education venues. Continuous effort for maximum gameplay is needed. It's used with serve, set, hit, and pass motions. Over 650 jump and land impacts per week for male athletes. Projectile motion has a major impact on the movement of the ball through the air. The goal is to hit the ball to the floor as quickly as possible and with as much momentum as possible. The physics of serving. Serving is the beginning of all volleyball play. Accuracy and consistency are gained by placing the ball at the same location relative to the shoulder. To optimize the serve, minimize the time the ball spends in the air. Top spin causes velocity on the top of the ball to become less than the velocity at the bottom of the ball. This velocity difference causes a greater pressure on the top of the ball, which causes a net downward force. This is all caused by Bernoulli's principle. The physics of passing. Forearm passes are directed at a specified target. A low trajectory pass also increases the setter's peripheral vision of the court. Gravity affects passing throughout the entire game, bringing the ball toward the ground every play. High trajectory pass causes the setter to look upward toward the apex of the pass, increasing the setter's field of vision of the roof. The physics of hitting. There are 7 phases to hitting: the preparation phase, landing, impulsive drive, airborne phase of preparation, hitting phase, airborne phase of landing, and landing. During the preparation phase, the athlete must gain maximum momentum and height. During arm swinging, the kinetic chain comes into play. This just ensures force from the athlete's body is being transferred into the ball. In order to gain the most accuracy and power, contact should be made when the athlete is at their peak height. Isaac Newton's 3 laws in volleyball. Newton's first law. An athlete needs to overcome their body's inertia in the jump by changing their state from rest to vertical motion. Newton's second law. To overcome their body's inertia, a force needs to be applied. The lower the body weight and mass of an athlete, the more they can accelerate their body to maximize jump. Newton's third law. In the jump phase, the athlete applies a force to the ground, which in return applies a force back on the athlete, overcoming inertia. All 3 laws together. The athlete needs to overcome their body's inertia by applying a force which will lead to an equal and opposite reaction that accelerates the athlete.